Section 2.2 is on the definition of derivative. Derivative is an expression that calculates the instantaneous rate of change or the slope of the tangent line. So derivative is a fancy word for slope of a function at any given x value. In other words, it gives us the slope of the function at a point. Okay, so this is the function. The function is f of x equals x squared. This is the equation of the derivative. It has a little apostrophe here. We say the derivative of f, or we say f prime x is another way to say it. So they're telling me f prime of x is 2x. Okay, so if I want the derivative of f at 0.1, or at x equals 1, I'm going to plug in 1. 2 times 1 is 2. Now, derivative is saying the slope of the function, of the tangent line to a function at that point. So at x equals 1, if I drew the tangent line here, let me try. Okay, this is the tangent line to this function at x equals 1. According to this, the slope should be 2, up 2 over 1. So it actually did work. Okay, let me try, if I plug in 2, the slope of the function f at x equals 2 should equal to 4. So if I were to go to the graph at x equals 2 right here, and if I were to draw the tangent line to that point, in theory, it should be equal to 4. Mine's probably off a little, but that's okay. You can definitely tell it's steeper, so it would be 4. If I plug in negative 2, 2 times negative 2 would be negative 4. So the slope of the tangent line to f at x equals negative 2 should be negative 4. Negative 2 is over here. If I were to draw the tangent line here, okay, that doesn't look good because it overlaps. Let me try again. Like that, maybe. The slope of this line should be negative 4. 1, 2, 3, 4. Oh, actually, it's pretty close. Good, but it's definitely negative over there, and it is pretty steep. Okay, so for example 1, they're telling you the equation of f prime of x equals 5 over x minus x. They want you to find f prime of 2 and explain the meaning. Okay, so I'm just going to plug in 2. What is 5 over 2? 5 over 2 is 2.5. 2.5 minus 2 is going to be 1/2. Okay, and then what is the meaning of this value? Okay, it's the derivative, so that's going to be the slope of the tangent line at, what did we plug in for x? 2? At x equals 2 is 1/2. So that's the slope of the tangent line. Okay, for the next example, they're just going to have you interpret the expression based on the word problem. So if f of x represents how many meters you have run and x represents the minutes, describe in full sentences the following. Okay, so the first one is f of 8. Okay, let me see. F of 8. F of x is how many meters you have run. X is the minutes, so it's going to be at 8 minutes. So at 8 minutes, I have run, does that sound right? I have run 1,500 meters. That's what the function is telling me. Okay, for the next one, they're saying this is the derivative of f at x equals 3. Remember, derivative is the rate of change. So I'm going to figure out what the rate of change is. I do know it's at 3 minutes, so I'm going to go ahead and say that. At minute 3, I am running I'm going to do a rate. My rate is going to be, what am I doing? Rate of change is going to be meters over minutes. So I am running at a rate of 161 meters per minute. Okay, there's various forms of notation to show a derivative. These are 2 of them. I think this is Lagrange. Okay, the Lagrange is where they use the little apostrophe, which is the prime. So I'm going to say f prime of x. I might say f prime of x, and that would be if my equation I'm starting with is f of x. If my equation I'm starting with is y equals, I might also do y prime. But it would match the notation of my original function. If it was y equals x squared plus 5 versus f of x equals y squared plus 5. The other one is Leibniz. It might be Leibniz, I don't know. Okay, that's going to tell you one in terms of another. So I'm going to say dy dx is the most common form. We're going to say, we often say dy dx, that's the lazy way. But what we're really saying is the derivative of y with respect to x. Okay, and the y is your dependent variable, the x is the independent variable. So in this case, it would be equation like y equals x squared plus 5. When I calculated the derivative, it would be dy dx, or the derivative of y with respect to x. If it were a different function like p in terms of t, then I might do dp dt, but that would mean my equation was p equals something in terms of t. Okay, it doesn't matter which one's which. Just know that they all mean the same thing, and we use them interchangeably depending on the original notation. Okay, so this is going to be the definition of the derivative. That's totally spelled wrong. Okay, this is the expression we learned in the last section because the derivative is really the instantaneous rate of change at a point. The formula we learned last section for instantaneous rate of change is actually the formula for the derivative at a point. So I'm going to say f prime of x is equal to, one of the ways we learned it was the one where h approaches 0. This is the formal definition of derivative, and this is how we did it last section. We just called it slope, or we called it instantaneous rate of change. But as h approaches 0, you're trying to find the rate of change exactly at x, which is really f of x minus f of x, but h is super close to 0, and you're dividing it by 2 points that are super, super close to 0, which is why h is approaching 0. Okay, so for these problems here, we're going to find the derivative, and they want you to use the definition of the derivative, so that formula we just wrote, because we'll learn shortcuts eventually, but when they say definition of derivative, they want you to use limits to evaluate the derivative. Okay, since I'm starting out with f of x, for notation, I'm going to say f prime of x is how I will find the derivative. Okay, if I use the formula, it's the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, then I'm going to go ahead and plug it in. Okay, if I plug x plus h into this function, I'm going to plug it here, and I'm also going to plug it here. I'm also going to have a lot of stuff. 2 times x plus h squared minus 7 times x plus h plus 1. Okay, then I'm going to subtract f of x. f of x is the expression exactly as it is. I'm going to put it in parentheses so I don't forget that I am in fact subtracting. Okay, and then the entire thing is over h. Okay, now I'm going to go ahead and simplify this. I am going to keep writing the limit as h approaches 0 until I plug in 0. I'm not going to plug in 0 yet, because right now if I plug in 0, I'm going to get 0 over 0. Okay, 2 times, if I do x plus h times x plus h, that's x squared plus hx plus 2hx's plus h squared minus 7x minus 7h plus 1. I'm going to go ahead and distribute the negative here. Negative 2x squared, positive 7x, minus 1, the whole thing over h. Okay, let me distribute that 2, and then we can get to canceling. 2x squared, 4hx, 2h squared. Should I cancel these? Oh, I see these cancel now. Let me cancel them now since they're there. They're tempting me. Minus 7h plus, oh, the 1's cancel too. Let me cancel those two. 1 minus 1. Less writing. Okay, so I cancel minus 7h minus 2x squared. Okay, this entire thing is over h because I have not plugged anything in yet. Okay, now this is looking a little bit better. Okay, the 2x squared minus 2x squareds cancel out now. So I am left with 4hx plus 2h squared minus 7h divided by h. Okay, I'm going to go ahead and cancel an h out of all the terms. I could also factor the h out first, but I can see that this has an h, this has an h, and this has an h, so I'm going to go ahead and get rid of them. That's going to go down to 4x plus 2h minus 7. Okay, after all that work, now I'm going to evaluate the limit as h approaches 0. So I'm going to plug in a 0 right here. And I'm going to get, what is that, 4x. 2 times 0 is 0 minus 7. So the derivative of f of x is 4x minus 7, or I could say f prime of x is 4x minus 7, and I use the definition of derivative to find it. Okay, I'm going to go ahead and do the same process for the next one. Okay, in this case, they're telling me that y equals 1 over x squared. So notation-wise, I could use y prime, I could use dy dx. I'm going to use dy dx, it's a little bit more formal. So to find the derivative, I'm going to find dy dx, which is the derivative of y with respect to x, because it's y equals, and this has an x in it. Okay, I'm going to use the formal definition again. H approaches 0. I'm going to do f of x plus h. So I'm going to plug the x plus h in here. 1 over x plus h squared. I'm going to subtract f of x, 1 over x squared, and I'm going to put the entire thing over h. Okay, and I'm not going to be able to plug in 0. You could always try, though. If I plug in 0 here, I get 1 over x squared minus 1 over x squared, which is 0 over 0, which is terrible. Okay, let me get rid of my complex fraction. Okay, remember there's more than one way to do it, and it's up to you how you would like to do it. I'm going to cancel them out by multiplying by what I want to get rid of. So I'm going to multiply by the x plus h squared, and also by the x squared. If I do it to the bottom, the numerator, I have to do it to the denominator. Okay, if I do this carefully to the numerator, my fractions will go away. Okay, the x plus h squared cancels, and I'm left with an x squared minus. The x squareds cancel, and I'm left with an x plus h squared. Okay, in the denominator, what do I have? I have the little h, I have the x plus h squared, and I still have the x squared. Okay, now I'm going to simplify the numerator. Now I'm going to distribute this out and then cancel it. Remember, if you recognize this as a difference of squares, you could factor it using a difference of squares, and it would save you a step or two. But I think most people do it by simplifying, so I will do it that way. X squared minus x squared plus 2hx, plus h squared. Okay, and I kept the denominator the same because I'm just waiting for things to cancel. Okay, let me see what's left. X squared minus x squared are going to cancel. If I give the negative to the 2hx, I'll have negative 2hx. And if I distribute the negative to the x squared, negative h squared. Okay, and then the entire thing is over h times x plus h squared over times x squared. Okay, I'm going to cancel an h out. This one has an h and this one has an h. I could factor the h out first and then cancel it, but because it happens so often, I'm just going to cancel it. Limit as h approaches 0. If I cancel the h out, I am left with negative 2x, and then if I cancel an h out, I'm left with h. And then the bottom, the h canceled, so I have x plus h squared times x squared. Okay, even though this looks terrible, I'm now going to do direct substitution and plug in 0 to see what I get. Okay, if I plug in 0, I have negative 2x minus 0, which is just negative 2x. If I plug in 0 on the bottom, I have x plus 0 squared, which is just x squared times x squared, which is negative 2x over x to the 4th, which I'm going to simplify in the tiny space at the bottom. So dy dx is going to be negative 2 over x to the third. Okay, that's a derivative, which also remembers the slope of the tangent line at various x values depending on which you plug in. Okay, last thing, we're going to do the equation of the tangent line. Now that we know we can find the slope of the tangent line, we're going to write the equation of the tangent line. So the line tangent to the curve of f of x at x equals a can be represented in point slope form. Okay, this is point slope form right here. My ordered pair I'm plugging in is going to be a, x is a, and f of a. Instead of m, remember that's the slope is the derivative. So since my function is f of x, m is the derivative, which is f prime x. For my x value, I'm going to have x minus, they're telling me to plug in a, so I'm going to plug in a. And in the y values, I have y minus the y value at a, which is f of a. Okay, and this equation is the exact same as this one. We're just using it in the notation of derivative instead of what we had before. Okay, so let's go ahead and look at what we can do now. Okay, so for number 2, if we know that h of 5 equals negative 2, keeping in mind they're giving me an x value and a y value already. And the derivative of h is given by h prime of x equals x cubed minus 2 over x. Remember, this is giving me a formula for the slope. Write an equation for the tangent line to the graph of h at x equals 5. Okay. So I already know that x equals 5. I know that y equals negative 2. I just need to figure out the slope, but I want the slope at positive 5. So to figure out the slope, I'm going to plug 5 into the derivative, which is 5 cubed 125 minus 2 over x, which is 5, which is 123 over 5. So now I can write the equation of the tangent line using point slope form. So it's going to be y minus negative 2, which is positive 2, equals, the slope is 123 over 5, and then it's x minus the x value is 5. Okay, so this is the equation of the tangent line in point slope form. Okay, last example. We're going to write the equation of the tangent line again, but they're going to give you the information in a different way. But as long as you know what you have and what you don't have, it's fine. Okay, this is the graph of f prime of x is this one. This represents the derivative of f of x. They're telling me that f of 2 is 7. So they're telling me the x coordinate is x, the x is 2, the y is 7. They want me to write an equation of the tangent line to the graph at 2, 7. Okay, so I know the x value, I know the y value, I just need the slope. The slope is the derivative at that point. So again, m equals, what is that? That's the derivative at x equals 2, because that's the value they want me to figure it out from. Okay, now the graph of f prime is graphed here. So if I go to x is 2 on this graph, that means f prime of 2 equals this. And that's why they gave me the graph. So f prime of 2 is equal to 3, which is my slope. So now I can write the equation. So it's going to be y minus the y value equals the slope times x minus the x coordinate. And that's my equation in point slope form.